Hi girls, so this video is on benzene. Benzene is in the Some Families of Organic Compounds chapter on page 400 in your book. So just looking at the syllabus, what you need to know about benzene is you need to know its structure. You need to know the structure of ethyl benzene and methyl benzene as well. You need to know about the physical properties of benzene, so things like its solubility, and lastly, then you need to know the uses of benzene. So we'll start off looking at the structure. So you might have seen benzene before in your fuels chapter, drawn like this with a circle in the middle. But I'm going to draw out the skeletal structure of benzene. So we're going to actually draw out what this looks like. So we have 6 carbons in a cyclic structure like that, and each of these carbons has 1 hydrogen. Didn't leave myself much room there, but each of these carbons has 1 hydrogen. So basically what this circle means in the center of the symbol is that each of these carbon-carbon bonds are identical. So they're all single bonds, they're all the same length. So instead of symbolizing that any other way, we just say that we put a circle in the middle to say that it's they're all identical. That's all that the circle in the middle means. And the other thing to note is that each of these bonds, all of these bonds are sigma bonds. So you know that each carbon has 4 electrons in its outer shell. So carbon should form 4 bonds. But in the structure for benzene, when we look at it like this, we can see that there's only 3 bonds around each carbon. So let's look at this carbon here. It has 1 bond to this carbon, 1 bond to this carbon, and 1 bond to the hydrogen. So that's 3 of its 4 electrons being used up in these sigma bonds. But each of these carbons still has 1 left over. So what happens there? Well, if I redraw carbon out using the simplified symbol, redraw benzene out using the simplified symbol, as you know, each of these corners represent a carbon and we don't have to draw in the hydrogens. So what happens with that extra electron? Well, the extra electron is in a p orbital in each one of these carbon atoms. So we have 6 p orbitals where the carbon atoms are located. And what happens is we have pi bonding occurring then. So remember, sigma bonding is the head-on overlap of orbitals, pi bonding is the sideways overlap. So you can see that between each of these p orbitals, we have pi bonding. So these are going to sort of interact with each other sideways and form what we call pi bonds. So what happens is we end up with a structure with that looks like this. So we end up with an electron cloud slightly above the benzene ring, and also an electron cloud slightly below the benzene ring. And these electron clouds are sort of donut shaped. And we call these electrons delocalized electrons because they're not located between the carbons and the hydrogens. They're sort of located above and below the benzene. So they're called delocalized electrons. And this structure here, because we have an interaction here, not just between 2 carbons, this interaction occurs between all 6 carbons, and that gives this structure extra stability, which is important to note as well. So this is a very stable structure. So that is basically the structure of benzene, and there is a good table in your book there which just sort of summarizes those details there, and that's on page 401. So I would advise you to look over that. Okay, so moving on from the structure of benzene, we're going to look at the structure of methylbenzene and also ethylbenzene. So all you need to know is that methylbenzene looks like this. So it's just a benzene ring with a CH3 off of one of the carbons. So that's methylbenzene. So I'll just write that in here. Methylbenzene. And then ethylbenzene looks like this. So again, we have our benzene molecule, and we have a carbon which has 2 hydrogens off of it as well, and then we have CH3. So that is our ethylbenzene. So you need to know the structures for those 2 molecules for your exam. Okay, so that's the structure finished, and now we're going to look at the physical properties. So I have some of them written out here. So the physical properties of benzene. Well, benzene is a non-polar molecule due to a small electronegativity difference between the carbons and the hydrogens. So therefore, it's soluble in something like cyclohexane, because cyclohexane is also non-polar, and it'll be insoluble in anything that's polar, so for example, water. It's also important to note that methylbenzene is used as an industrial solvent, so it's very useful, and we have another name for methylbenzene, which is toluene. So that's its more common name that would be used in industry. Benzene itself is carcinogenic, which means that it can cause cancer if you're overexposed to it. But it's important to know that not all aromatic compounds are carcinogenic. So benzene is just one example, but we, as you might know already, we have plenty of everyday uses for other aromatic compounds. And you do need to know some examples of those. So let's just talk through these. We have pharmaceutical compounds is one example of a use of aromatic compounds, and that would be something like aspirin. So for each of these you need to know an example, just the name of it, but you don't need to know the structure. So we'll just go through these. A dye, so an example of a dye would be chisodine. I'm not sure if that's how it's pronounced, but we'll go with that. Detergents then, sodium dodecyl benzene sulfonate. So like a detergent, a laundry detergent, you might see that ingredient on the back. A herbicide is a bit of an easier one. DDT is an example. And your acid-base indicators that we've used in the lab, so methyl orange and also phenolphthalein as well, are also aromatic indicators. So they contain an aromatic compound. So you'll see each of these examples and more given in your book on page 401. So as I said, you do need to know one example of each of the ones that I've gone through. So you need to know one example of a pharmaceutical compound, one example of a detergent, one example of a dye, one example of a herbicide. They're the main ones that I'd focus on. So you just need to know the names, and you don't need to know the structures. So that's it for benzene. So let me know if you have any questions, and I will post a couple of exam questions on benzene as well.